Welcome to a lesson about sinusoidal functions and their graphs. Today's objectives are to be able to demonstrate an understanding of the sine and cosine functions and their graphs, to be able to identify and interpret the amplitude, period, and vertical shift of a sinusoidal function, and to be able to write and analyze the formula for a sinusoidal function that is given graphically, numerically, or verbally. Sinusoidal functions. We often model periodic phenomena using transformations of the sine and cosine functions called sinusoidal functions. You can think of things that are periodic, such as Ferris wheels, sound waves, bouncing springs, or even the tide in the ocean. We've seen a few problems that deal with these things. There are other objects that also have periodic behavior that we would then use a sinusoidal function in order to model it. So sinusoidal functions are sine or cosine curves. And what we do is we take y equals sine of x and y equals cosine of x, and then we just transform them. So most of these are just transformations of sine x and cosine x. So if you'll remember back when we talked about transformations, our basic transformation of any function is a times f of b times x minus h plus k, where a is a vertical stretch or compression, b is a horizontal stretch or compression, h is a horizontal shift, and then k is a vertical shift. The same is true for all of these sine and cosine functions and sinusoidal functions. So your a is your vertical stretch or compression, and that affects the amplitude because it'll stretch it, make it taller or make it shorter, and so it'll make it a larger or a smaller amplitude. And if you'll remember, amplitude is a vertical distance, so it is never negative. That's why we say the amplitude is the absolute value of a in the front. If there's a negative in the front out here, so this is positive or negative in the front, the negatives in the front just means it reflects over the x-axis. So our period gets affected by a horizontal stretch or compression. And we talked about this the other day. So our period becomes 2 pi divided by b, because on the inside everything happens opposite of what you think it's going to happen. So if b is larger than 1, it is a horizontal compression by a factor of 1 over b. And if b is less than 1, it's a horizontal stretch by a factor of 1 over b. Then b is less than 1, so when you divide 1 by a number less than 1, it becomes larger than 1. H will tell us our horizontal shift. And if t minus h on the inside, or it could be x minus h, it depends what your input variable is, but whatever it is, x minus h or t minus h, that's a shift right. T plus h or x plus h is a shift left. So remember, it happens opposite of what you think is going to happen. Our midline value is this k value at the end, because that's a vertical shift. And our regular sine and cosine function, the midline is at y equals 0. And so when we shift our cosine or our sine function up or down, then our midline also shifts up or down. So y equals k, this value k out here is your equation of your midline, but it also represents a vertical shift. So if a question asks you for the vertical shift or the equation of the midline, that k value should be exactly the same. So let's do a few examples. We're going to state the period, midline, amplitude, and then the horizontal and vertical shifts of the following sinusoidal functions. Something that's important to note is that it must be written in these forms. So you'll notice the b value is factored out in front of t plus h or t minus h. It cannot be next to the t or the x value. It must be factored out. So one thing I always look at when I'm starting these is that b value factored out? And it's not. So I need to rewrite my function where the b value is factored out. So it's 2 cosine, and I'm just going to factor pi out. And so I will take pi times x and divide it by pi and get x. That's what's left there. And then I'm going to take 2 pi over 3 and divide it by pi, which is the same as multiplying by the reciprocal, so 1 over pi, and then I will be left with 2/3 on the inside. Everything else is the same. So now we're going to find the period, midline, amplitude, and then the shifts. So the period, we're going to use the b value. And so remember, the period is equal to 2 pi over b. So we have 2 pi over pi, and the pi's will cancel out, and we're just left with 2. So this graph has a period of 2. Now remember, your x-axis, those are your radians, so this is a measure of 2 radian units long. Then our midline is just the k value at the end, so it's an equation of a line though, so we're going to write y equals -1. Our amplitude is the a value out in front, so that would just be 2. Our horizontal shift is this h value, and it's opposite opposite of what we think. So we're going to go left 2/3 units. Our vertical shift is the K value at the end, so we're going to go down 1. So notice the midline and the vertical shift are the same. We go down 1 and we take that midline from y equals 0 and move it to y equals -1. So let's look again. We're going to do number 2. So the first thing you always want to look at and see if that b value has been factored out. And again, this one has not, so we are going to factor it out. So let's divide 2 by 2, and that's just 1, so we're left with x. And then when we divide 7 pi by 2, we get 7 pi over 2. So again, the period is 2 pi divided by b, and this time b is 2, so 2 pi divided by 2 is pi. So the amplitude is this a value, but it's the absolute value of it because the negative in front is just a reflection. So the amplitude is 4. Our midline is y equals 2 because it's the k value at the end. Horizontal shift is the h value, and so it's negative in there, so we're going to go right this time, 7 pi over 2 units. And then our vertical shift is up 2 because the k value is positive 2. So let's talk about constructing a sinusoidal model. So you're given information or you're given a graph, and we're going to figure out the equation of the sinusoidal function that we have. So first of all, you want to determine what is the function. So you're going to select a starting point on the y-axis, because remember that's where you start your graph when x equals 0. If the starting point is on the midline, then you're going to use the sine function. If the starting point is at the maximum or the minimum, you will use the cosine function. And then if it doesn't start on any of those points, you're going to pick a point close to the y-axis is usually where you want to go, and then identify a horizontal shift. Something to remember about sine and cosine functions is the regular sine function, sine of x, starts at the midline, which is normally y equals 0, and is positive first. So if there is no reflection, it's a positive sine function. It'll start at the midline and then be positive first, so go up first. A negative sine function will still start at the midline, but it's going to be reflected, so it'll go down first. A regular cosine function, or a positive cosine function, where there's been no reflection, is going to start at its maximum value, because if you'll remember, cosine starts all the way out on the right, far right, when you are going around your circle, and it's your over distance. So that would be the maximum value of your graph. Then negative cosine is going to reflect, and it will start at the minimum value. So the next thing you want to do is determine your maximum and your minimum values of your graph. Those are going to help you find the amplitude and the vertical shift. So you can use to find the vertical shift or the equation of your midline for k, you can do the average of the max and the minimum and then divide by 2. To find your amplitude, you can subtract them, so you find the distance between the two and then divide by 2. Or you can just take your max and subtract your midline, and that's another way to find your amplitude. Also, don't forget, changing the sign of the constant a out in the front will just reflect the graph over the midline. You also then want to find the period. So if you're looking at the graph, you're going to look at the period and determine a place where the graph starts and ends the pattern, and then before it starts repeating again. So figure out what that horizontal distance is, that is your period, so that you can then find the b value to write in your equation. And the b value, if you'll remember, is just 2 pi over the period. So let's look at this worked example. So we have a graph here, and what we want to look at is, first of all, figuring out where the starting point is. So remember, the starting point, if possible, is the point on the y-axis. And as long as it's a maximum, minimum, or a midline value, that is the point you want to use as your starting point. So this starts at the maximum. And so since it starts at the maximum on the y-axis, this is a cosine function, and there is no horizontal shift. There's also no reflection. So this is a positive cosine function. The next thing we want to find is the amplitude. So our max value is 5, and then our minimum value is 1. So we will add 5 and 1 and divide by 2 to find the midline, and then we will take that max value and subtract the midline to find the amplitude. So the midline is 3, and then the amplitude will be 2. Since the midline is 3, there is a vertical shift up 3. Then we'll find the period, and so you can count the period from here to here, and that's 4 units, but you could have also counted the period from here to here, from here to here. It doesn't matter, just so long as you're getting one complete piece of the pattern before it starts repeating. So this has a period of 4. So to find the b value, do 2 pi over 4, which equals pi over 2. And so then you'd write your equation. Since it's a positive cosine function, you could just write your function function and then just add the positive or negative in front. You don't need to add a positive in front, but you need to add a negative if it's a negative cosine function. So remember, it's your amplitude A, and then this was a cosine function we said, so it's cosine of B times X. There's no horizontal shift, so we don't have to worry about H. And then you would close off your parentheses and then put plus K at the end. K was negative, you would just subtract K from the end. So let's do a few examples. Example 3 says to find the sinusoidal function whose graph is shown. So we're going to find the starting point first. So our starting point is right here, and that's a maximum value. So we're starting at the maximum, which makes this a positive cosine function, and it has not been flipped. There is no reflection at all. Then, since it starts right on the maximum, there are no horizontal shifts either. The max value is 3, and your minimum value is negative 3. So we're going to find the A and the K value. The K value, we're just going to add the two values and divide by 2 and get 0. And if you want, I would draw in the midline so that you could see that it is halfway between the top and the bottom. Then your amplitude, you can just take your max and subtract the midline and get 3. Now we need to find the period. So we could go from max to max because that would be one time around. Think of riding on your Ferris wheel, going from the top to the top. And so we're going to find the period, which is 4 on this graph. That's the easiest place to use to find the period. And then we need to find the B value, which is 2 pi over the period, or pi over 2. So now when we write our equation, we'll write y equals A, which is 3, and then we said this was a cosine function of pi over 2x, and then plus 0 because there is no K value. It's also positive cosine, so we don't need to add a negative in the front. For question number 4, we're going to also find a formula for the sinusoidal function, and we're going to select a starting point. You'll notice on the y-axis it does not start there at a maximum, minimum, or a midline value. So just pick one of those 3 points that's close by that's easy to figure out the horizontal shift. So this one right here is a good place to go because it's just one to the right. You could also use this one down here if you want, but I'm going to start at this point right here at the maximum. Based on that starting point, this is a cosine function that has not been flipped. So it is a positive cosine function. It has been shifted to the right 1 unit. Notice if I had chosen this other point as my starting point, it would be a negative cosine function because that's a minimum point and that was shifted left 2. So it would change whether it's positive or negative cosine, and it also changes the shift. So let's identify the maximum and the minimum value. Our maximum value is at 1 and our minimum value is at negative 5, so that our midline is at 1 plus negative 5 divided by 2, or negative 2. So I'm going to draw in our midline and see that I do in fact have half the graph above and half the graph below. The amplitude is the max minus the midline, and 1 minus negative 2 is 3. You can also, if you would like, just count the units that it is. So the period of this graph, you can always go from max to max, mid to every other midline, right? Because if you're riding the Ferris wheel, you're going to be half the distance to the ground every half a turn, or you can go from the minimum to the minimum. So I'm going to go from here to here and then just count the horizontal units, and that would be 6. So then your B value would be 2 pi over 6 or pi over 3. So now we're going to write our equation. So this is y equals, and then the amplitude was 3, cosine of B, and this time we do have an h value, so we have to put that in parentheses and do x minus 1 since it was right 1, and then we're going to subtract 2 on the end because that's our K value. Okay, for example number 5, first of all we look for a starting point, so look at the y-axis. Notice it starts at the minimum value. So that would be a negative cosine function, and so yes, it has been flipped because it's not positive, it's negative, but there is no horizontal shift because it starts at the minimum on the y-axis. The maximum value is 6, your minimum value is 0, so the K value would be 6 plus 0 divided by 2, or 3. That's where your midline is. The A value would be 6 minus 3, or 3. If you'll remember when we did the Ferris wheel problem, if your minimum is 0, then your amplitude and your K value will be the exact same number. The period for this function is 4 pi, so if you go from minimum to minimum, you'll see that it's 4 pi, and your B value would be 2 pi divided by 4 pi, or just 1/2. So your equation is y equals negative 3 times the cosine of 1/2 x plus 3. If you look at number 6 and try to find a starting point on the y-axis, you're going to notice that it doesn't start at its minimum, midline, or its maximum. So you get to choose the starting point. And so look for a one that is close to the y-axis. So you have your choice of any of those three ones. You could start at the minimum, midline, or maximum. We're going to start at the midline because we haven't done one yet that way. And so that is a positive sign because it starts at the midline and goes up. So it has not been flipped, but there is a horizontal shift. It has been shifted to the right one. And it went right one because normally you start on the y-axis, but it has been shifted to the right one and it's starting at 1 instead. Your maximum value is -1 and your minimum value is -3. So to find the k value, you take the average of the two and add -1 and -3 and divide by 2 and get -2. And that would be your midline. Your amplitude would be -1 minus -2, and the double negatives become positive, so it's 1. Or you could just count and see that that's a unit of 1. The period, go from minimum to minimum and just count over, would be 8. So that your b value is 2 pi over the period, or pi over 4. So that your function becomes y equals, your a value is 1 and it's positive sign, so you don't really need anything out in front. So it's sine of pi over 4. You need your extra set of parentheses, x minus 1, and then minus 2 on the outside because k is negative. Your homework is to do the 9.3 day 2 worksheet. Please let me know if you have any questions and have a great day.